Okay, hello everybody. So today we're going to continue our discussion in Chapter 4, Section 1, and I'm going to show you some application problems in regards to asymptotes and what they mean within the context of a real-world problem. So let's get started. It says a utility company burns coal to generate electricity. The cost C in dollars of removing P% of the smokestack pollutants is given by C equals 80,000 P divided by 100 minus P, where P has to be from 0 to 100. It says sketch the graph of this function. It says you are a member of a state legislature considering a law that would require utility companies to remove 90% of the pollutants from their smokestack emissions. The current law requires 85% removal. How much additional cost would the utility company incur as a result of the new law? So let's talk about this equation right here that we have. It says C equals 80,000 P divided by 100 minus P. Now, this equation gives us the total cost of removing pollutants based on the percent that is removed. And you can see if it's set up, that's more a little easier way to understand. So you plug in the percent of pollutants that you want to remove, and then this equation will give you an idea of how much that is going to cost to remove those pollutants. Now, they wanted us to sketch a graph of this first. That's pretty simple. You can simply just type it in your graphing calculator. You do have to adjust the window slightly, or you could hit Zoom Fit. But when you do get the window adjusted, you're going to see a graph that looks something like this. So it's very cheap to not remove any of the pollutants. But as we continue to remove more or higher and higher percentage of pollutants, you can see the cost of that is increasing. It almost looks like an exponential graph, although it's technically not. You can see the growth goes up awful fast. So this was what the graph would look like. Now, it says, note that the graph has a vertical asymptote at P equals 100. So my first question would be, well, why is there a vertical asymptote right here at P equals 100? Well, if we go back to look at the equation, you can see that the original equation is 80,000 P divided by 100 minus P. And if you recall from the last video, in order to find your vertical asymptotes, you actually take the bottom. For vertical asymptotes, you take the bottom and you set it equal to 0. Well, if I did that and then I added P to the other side, you can see that the vertical asymptote is going to occur at 100. That's why you see that there's an asymptote there. Now, the second part says the current law requires 85% of the pollutants to be removed. How much additional cost would the utility company incur as a result of the new law? And the new law is requiring 90%. So what we would need to do is take this equation that we have, and we need to plug in 85 and plug in 90 and come up with a cost for each one of those. And they want to know how much additional cost it would be, so then you would subtract the two. So we have, the first part is 80,000 times 85 over 100 minus 85. So that's going to give us our cost for our first one. The cost for the second one is going to be 80,000 times 90 over 100 minus 90. Now, if I take my calculator and I go ahead and type that in, we're going to take 80,000 and multiply by 85. And then we need to divide that by 100 minus 85. That would be 15. So I'm just going to hit divided by 15. And you can see that it would cost $453,333. So 453,333 cents. So there's our cost for the first one, 453,000. Now I'm going to go ahead and do the same thing, 80,000 times 90, and then I'm going to divide that by 100 minus 90, which is 10. And when I do that, I get $720,000. So now they want to know what the increased cost was. So I simply subtract those two numbers. I take 720,000 and I subtract away the 680,000, or excuse me, 453,000. And when I do that, the answer, so I have 720 minus 453 is equal to, I'm kind of running out of room here, but it's going to be $266,666.67. So there is the total increase in cost if they raise the amount that they need to remove from the smoke. Now, another problem I want to show you, it says for a person with sensitive skin, the amount of time, T, in hours the person can be exposed to the sun with minimal burning can be modeled by this model. It says where S is the Sunser scale reading, the Sunser scale is based on the level of intensity of UVB rays. It says, find the amount of time a person with sensitive skin can be exposed to the sun with minimal burning when S is 10, 25, and 100. So that first part is pretty straightforward. You're simply going to take your graphing calculator and you will plug in 10, 25, and 100 into the equation. Now, I'm actually going to go into Y1 and make sure plot 1 is shut off if you still have that turned on from back whenever we did scatter plots. But I'm going to enter this part in. So I'm going to put a parentheses, 0.37x plus 23.8, and then divide that by x again. Now, once I have that entered in, I'm going to go ahead and hit second window, and I'm going to change the first independent to ask. Now I'm going to hit second table. Now once I do that, it will allow me to put whatever numbers I want in. In this case, I want to plug in 10 and 25 and then 100. And you can see this is a very quick way to find the answers that we're looking for. So you can see when I plug in 10, it's 2.75. When I plug in 25, it's 1.322. And when I plug in 100, it's 0.608. Now it says find the amounts of time a person with sensitive skin can be exposed to the sun. So remember, T is in hours. So depending on the intensity of the sun, as the intensity of the sun goes up, the amount of time that they can be exposed to the sun without burning is reduced. So there's part A. Part B says, suppose the model was valid for all s's greater than 0. What would be the horizontal asymptote of the graph of this function? And what would it represent? So let's take a look for a second. How do we find horizontal asymptotes? Remember, vertical asymptotes are found when you set the bottom equal to 0. Horizontal asymptotes are found when you compare the top and the bottom powers. So looking at the power in this particular problem, we can have s to the first here and s to the first here. So the powers are the same. When the powers are the same, you are to divide the lead coefficients. So the lead coefficients here are 0.37 and 1. So our horizontal asymptote then is going to be y equals 0.37. Okay, so now that we found our horizontal asymptote, we need to understand what that means within the context of the problem. So it would be very helpful to actually just look at a graph of that equation. And if you see the graph right here, you can see that we have the sun sensor scale, or the intensity of the sun across the bottom, and then we have the exposure time on the left-hand side. And what you can see as the sun sensor scale increases, as we go from left to right, and the intensity is increasing, the amount of time that we can spend in the sun is majorly decreased. So you see this horizontal asymptote right here, way down at the bottom, that the graph is approaching, that it won't ever cross that. And it says the horizontal asymptote is the line t equals 0.37. And this is the line that represents the shortest possible exposure time with minimal burning. So hopefully that made sense. As always, if you have any questions, feel free to email me. Have a great day.